if we can find something like that will help. Which statement did you use?
Well, the converse of AIAT, it was like the converse of AIAT is if two lines are parallel, then the alternate interior angles are parallel. So
Oh, wait a minute. If two line, what we need to show is if you have two parallel lines, they are already given. We have to show that angle.
You mean we already have to prove that?
Yeah, no. We are, see, what is the converse? What is AIAT?
AIAT is if the alternate interior angles are equal, then the lines are parallel.
Right. This implies the lines are parallel. Right?
Now we have to. Should we prove the opposite?
Yeah. So it's not the opposite. It is the what is the
The converse.
This is AIAT, right?
The converse of that is if two lines are parallel, the alternating angles are equal.
Yes. So I have to show that if you are given two lines L and
yeah,
M.
but you told us to assume that converse of AIAT is true and then prove EPP.
Oh,
That's
I
what
see.
you told.
Right. So we are. Oh, we have to assume this. I see. We are given two parallel lines. Then I see. Oh, we don't have to prove this. I agree.
We don't have to prove this. We have to assume this and
we have to assume it, right? Hold on. So we have what we need to prove is given a line L and a point P, we have to show what? There is only one parallel to P. So first, it looks like this, I think. I don't know. Let us drop a perpendicular. Then let us construct another perpendicular here. Now let's call this M. We have to show that there is no other line through P that is parallel to L. Is that right?
Yeah, but we can. Oh, so what we have to prove is using the converse of AIAT. If the alternating angles are equal, the lines are parallel.
Right. So you are
then
right.
Then we have to use EPP.
Yeah,
we have to prove EPP.
We are, yes. So you are right. This is an easy problem. Suppose this is a line. I will call it N. We have to prove that N cannot be parallel to L. Is that right? Yes, Anushka.
Yeah, yes. That's right.
Sir, could I continue with the proof?
When you talk, hold on. I used to be like you, but I had to change. First of all, you need to be loud enough. I am actually over. I am too loud. You need to be slow. You need to be clear. When you talk, you need to be loud enough. You need to speak slowly and you need clear, okay? And of course, you should be, if you are teaching a class, make sure you have a happy voice, okay? Because your students are hearing you. And if you have a sad voice, and if you are not happy, I mean, it is not good. But these three are important. Anushka, say.
Okay. So could
Loud,
I continue
slow,
with the proof?
clear.
Could I continue with the proof?
Louder.
Could I continue with the proof?
Oh, your mic. Can you adjust it so that?
Check your microphone volume in Zoom settings. There'll be an arrow next to the the mute button, and then then click on audio settings. The second section is microphone audio. Make sure it's at max so I can hear.
Okay, can you hear me now?
Okay, let's try again. Go
Could
ahead.
I continue with the proof?
We are trying to prove EPP. That means, that's a good question, Anushka. It's always good to know what you want to do, isn't it?
Yes.
What do we want to do? We want to prove this guy. We want to show that a point not on a line accepts only one parallel to the given line. Agreed?
Yes.
We know there is one parallel. We proved it using AIAT, right? The
Yes.
converse of AIAT is going to tell us that you cannot have more than one parallel. So let us say there is one, right?
Yes.
Proof by contradiction. Let us say there is one. Then what does the converse of AIAT say?
Then if line if assume n and what's the other n and l are parallel by by the converse of AIT, the angle formed by the intersection of m and n is equal to the supplement of the right angle on the bottom.
The alternate, yes. So this angle has to be 90 degrees, agreed?
Yes.
If you are assuming the converse of AIAT, if this is parallel to L, this angle must equal this angle, agreed?
Yes.
Therefore, N equals M.
That's a
Is that what you all
contradiction.
got? There is only one parallel. That means EPP. Is that what you all got?
Yes.
Yes, Raghav? All right.
Actually, what you're saying is, if L is parallel to both N and M, angle N, angle 1, this is.
Yeah, angle 1, yes.
Angle 1 has to be equal to angle 2.
Angle 2, that's right.
If angle
Actually,
1 equals angle 2, they are both the same line.
Yeah. But angle 1 has to be equal to this alternate angle, but that is already here. Therefore, because this is 90, this is 90, therefore, this being equal to this must also be 90, therefore N equals M, therefore EPP. It is beautiful, isn't it? Do you now see that the converse of AIAT is therefore equivalent to EPP? Okay? This is the reason why you should be careful to distinguish between AIAT and its converse. Because the converse of AIAT is equivalent to EPP. AIAT is not. Follow? AIAT, namely, if you have two parallel lines, and there is a transversal, then angle 1 equals angle 2. This is the AIAT. This is different. This is a theorem in which geometry? This is a theorem in which geometry?
Neutral geometry.
Neutral geometry. This is a theorem in which geometry?
So it is in neutral geometry.
This is a theorem in Euclidean geometry. Why? Because this needs the Euclidean parallel postulate, which is equal to Euclid's fifth. Because Euclid's fifth makes neutral geometry Euclidean geometry. Clear?
Yes, sir. Sir, I thought
Neutral geometry plus EPP or EF, that is what you call which geometry?
Euclidean.
Euclidean geometry.
You told what is so what will be the thing? So like what will the people of hyperbolic geometry
Oh, we will come to that. We'll come to that. Hyperbolic geometry is neutral geometry plus, well, actually this is wrong. Yes, that is correct. Sometimes I have doubts. Neutral geometry is 1, 2, 3, and 4. These axioms of Euclid. To that you add the fifth axiom, you get Euclidean geometry. If you add the opposite of fifth axiom, you get hyperbolic geometry. What do you think would be the opposite of the fifth axiom? Yes. Yes. Smayan?
So here I had a
I can't hear what you are saying now.
I found a doubt.
Wait, Smayan is talking. Hold on. Smayan, something wrong with your microphone. We can't hear you.
Oh, sorry, sir, I was muted.
Okay.
Yeah,
Where
so
you go?
we have
Yeah.
to.
Go ahead.
Yeah, so what we have to do is we have to show that line M is the only line parallel to Q.
Yeah, that is what we just showed, right?
Yeah.
That's why EPP. So,
Yeah.
what is the opposite of EPP?
The opposite of EPP means that if
We know there is at least one parallel through P, don't we?
the opposite of EPP is that that won't work. We can't say that if there are two lines that are parallel, there is one point where you can draw a perpendicular from.
No. Let me, all right. It is time to NG plus this thing, only one parallel to L through P. If P is not on L, do you know this notation?
Yeah.
P contained in L, P not contained in L. If P is a point not in L, then we have to show, then EPP is, what is EPP then?
The EPP is that there's only there's one unique parallel line that goes through P.
Goes through M. There is only one line through P parallel to L. That is EPP, isn't it?
Yeah. That's what I said, but I said it in the...
Okay. What is the opposite of that? If you deny that, yes. Who wants to say it? Give me the
So it
name.
would be neutral geometry.
Neutral geometry said, watch this. If you have a line, the alternate interior angle theorem says, if you take two lines, and if you can draw so that these two are equal, if these two are equal, then the lines are, isn't that AIAT? Is this AIAT? If these two angles are equal, the lines are parallel. So that means that this allows us, given any line, to construct a parallel through a point P not on the line. Why? Because the easiest angle to construct is the 90-degree angle, isn't it? There is a construction for it in Euclid's Elements. In fact, I think it is proposition. I'm checking my Euclid. It is proposition 12. By Euclid's proposition 12 in the book 1, from any point you can construct a perpendicular to a given line. Now, by Euclid's proposition 11, you can construct a perpendicular to a line. Through a point, you can construct a perpendicular. See, the difference between this and that is, proposition 12 tells us from a point you can drop a perpendicular to a line. Agreed? Proposition 11 says, at a point you can construct a perpendicular to the line. These are different propositions. Anyway, there are these constructions that allow us to do this. By AIAT, what can you say about the line M?
Sir,
Yes.
by AIAT, the lines M and L are parallel.
Exactly. Because the alternate interior angles are equal. This is telling us AIAT, which is a theorem in neutral geometry, allows us to construct a parallel to a given line from a point not on it. Agreed? Agreed? If you take a point not on a line, AIAT allows you to construct a parallel to the given line through the point. Anushka, clear?
Yes, sir.
So what does that prove? So these are parallel. I keep telling you this thing, that if your mom told you to go to a building in the night and turn on the light there, and you went there, opened the door, you saw a head moving, you immediately closed the door, ran back home and told your mom, what did you tell her?
Sir, we told our mom that there is at least one.
Do you tell her that, mom, there is exactly one head moving inside?
No, sir. We tell her that.
Do you tell her, mom, there are at least two heads moving in?
No, sir.
What will you tell your mom?
Sir, we tell our mom that there is at least one
There is
person in the room.
Yeah, mom, there is at least one head moving in. There is at least one person in there. You only saw one head moving. That doesn't mean that there is only one person in there. Agreed, Rahav?
Yes, sir.
You constructed one parallel to L. Maybe there are more. Are you with me? AIAT tells that through a point not on a line, you can construct, there exists at least one parallel, and it constructs it for you. That is what neutral geometry can do. It shows there is a line through P that is parallel. Now, if you add Euclid's fifth postulate, which is equivalent to EPP, which says there is exactly one parallel, right?
Yes,
So
sir.
we have now in Euclidean geometry, how many parallels through P?
1.
One. Now, watch this. If you don't have this, if you don't have EPP, you leave open the possibility of having more than one parallel through P. Agreed?
Yes.
Now, it is difficult to imagine how you can have two parallels to P, parallels to L through P. At the end of this class or in the next class, you will see why you can have more than one parallel if you don't have this axiom. Okay? You can have the opposite of that axiom. You can say that there is at least two parallels. Does that violate this? Having at least two parallels, does it violate this condition? Siddharth.
Well, it all depends on neutral geometry. Neutral geometry says that there is more than or equal to one, at least one parallel to L passing through P. Hyperbolic geometry, which has the opposite of EPP, it doesn't violate the rule because there is a greater than symbol there.
Right. If we said, suppose we had said, could we say less than one?
Definitely not.
That will violate this.
And if it violates, it can't be a possibility because we have proofs.
When you are inside neutral geometry, you can get at least one parallel always. So you cannot add on a statement saying there is less than one parallel, because then there will be a contradiction. Would there be?
There would be a contradiction because neutral geometry says there is greater than or equal to 1. And say it's whatever geometry has less than one parallel. It would violate neutral geometry. But we have proofs to back neutral geometry. So obviously that has to go.
That's right. So this already gives us at least one parallel. So you cannot now say that I want to say that there is less than. If you said that, that will be a contradiction, wouldn't it? Agreed? Can you add, instead of EPP, you cannot add an axiom says there is at most one parallel. No.
You can't add an axiom, but what do you mean by not EPP? Is there an axiom that actually we can't imagine not EPP? Does it have a name? And more than that, how to imagine not EPP? And one more doubt, really, what does that not EPP axiom say? And what do you call it? And how to imagine it?
What is EPP?
EPP says if we have a line L and a point P, there is exactly one, more greater than or equal to, exactly one line passing through P. Yeah, there is exactly one line. Yeah, sometimes
What is the opposite of this?
the obvious opposite would be there is more greater than or equal to 2 lines. That's the obvious opposite.
Okay, the opposite of this will be not one, wouldn't it?
It would be not 1, but it has to be greater than or equal to 1.
Right. So you have to have not to one and greater than or equal to one. What do these
that
two? What do
greater
these
than
two?
or equal to 2.
Exactly. So this will give you greater than
If
one.
it's not
which is
1 and greater than 1, obviously, then it has to be greater than or equal to 2.
Exactly.
Or we
So
can say
that,
greater than 1.
so the opposite of EPP in neutral geometry will be greater than one parallel. That means, as Siddhartha said, at least 2 parallels to. Now, it is difficult for us to imagine 2 lines through P that do not meet L. Are you with me? I will show to you that you can draw 2 parallels. In fact, you can draw 3 parallels or 30 parallels or an infinite number of parallels. That geometry is called, so the opposite of EPP, that is what we are learning in this course. Soon, if you add the opposite, what geometry do you get? Yes, Anushka.
I was unmuted.
Anushka.
Hyperbolic geometry.
We get hyperbolic geometry. It is just like Euclidean geometry. It's beautiful. Okay. So now that we have done, so AIAT guarantees one parallel through P, not on L. Converse of AIAT is equivalent to EPP. So converse of AIAT is really in what geometry? It is in neutral geometry plus EPP, which is Euclidean geometry. A lot of people confuse AIAT with the converse of AIAT. If somebody asks you, what is AIAT? Yes, who wants to comment on it? Who has raised the hand? Yes, Anushka.
So the converse of AIAT is that given 2 parallel lines and a transversal passing through them, the alternate interior angles formed by the intersection of the transversal with the lines are congruent.
So is this correct? Is this picture correct here?
Yes.
Okay. On the other hand, AIAT is if you start with 2 parallel lines, then 1 plus 2, 1 equals 2. So if you want to, yes, this time someone else other than Siddharth speak. Siddharth took up already.
Okay. So what did you ask?
Who is talking?
Pakistan?
Who? Let me come to you.
Okay, so like if we are
Who
unable
is
to
talking? Wait a
distinguish
minute. Who is talking?
Vagisan,
I didn't get. T.A. Sundar, are you there?
Yes, sir. Yes, sir.
Okay. As soon as I find that I have trouble identifying a student, you need to help out.
Yes, sir. Vagisan. Vagisan is
Vagisan, I think the
I need to see your
just,
face. Can I see
further
your
away.
face?
Can you now hear me?
Wait a minute. I
his
need to see your
his
face.
video is on, sir. You can probably see.
How do you? I am struggling to find you. Vagishan, yes. Speak.
So if we are unable to distinguish AIAT and its converse, then it tells that we are unable to distinguish neutral geometry and Euclidean geometry, and that's very bad, right?
That's bad. You see, AIAT exists in what geometry?
All geometries,
Which geometry?
neutral.
Neutral geometry. Converse of AIAT, where does it exist?
Euclidean.
Euclidean geometry. Is this now clear? Clear. You know the public.
Yes.
See, in India, if you take our country, India, with 1.35 billion people, 10 to the power, is it 9?
Yes.
People, I don't think there is 135 people who know the difference between AIAT and the converse. There is hardly anyone who knows. I think it is one in a crore. Let me see.
No,
Yes.
1 in 1 million and 1 billion.
Yes. One person, one in 1 crore person at most will know the difference. You guys are very special, you know that? Very few people, most teachers don't know this. There might be 10 teachers in the nation who know this. There might be 25 professors who know this. And then there are you guys, 14 or 15 of you who know this. The difference between AIAT and converse. I stayed on top of it for so long because this is very important. It almost distinguishes these two geometries and informs you that the converse is to be taken seriously, not to be confused with AIAT. Now I will leave this topic. Anybody has a last question? All right. So, what shall I do next is the question. Well. Am I working without notes? That will be bad. All right. The next thing I want to do would be, so we know that we are in Euclidean geometry now. We have the SL theorem in neutral geometry. What does it say? Angle sum of a triangle is what? . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . Yes, Raghav.
Yes, sir. It is less than or equal to 180 degrees.
Yes. So I can see that most of you know that. Zachary-Legendre theorem says that it is at most 180 degrees. Now, we are in Euclidean geometry. I told you already yesterday that in a triangle, we are going to show that the angle sum of any triangle in Euclidean geometry is in fact 180 degrees. Now we are in familiar territory because you have heard that before, haven't you? In school, that is what we learn. Why is it 180 degrees? Because of EPP, we can draw now. Think of this as a line, then this becomes a point not on the line. Agreed? So you can draw now a unique parallel to this line. That would mean, suppose I say this angle is 1 degree, angle 1, angle 2, angle 3. What will be this angle? Raghav,
Sir, it will be angle 2,
the reason is why?
converse of AIAT.
Converse of AIAT, because we drew this line parallel to this line, and this is a transversal. Converse says the alternate interior angles are equal. How about this angle?
So
This
that will be angle 3.
angle 3.
Now, what is angle 1 plus 2 plus 3?
Sir, it will be 180 degrees.
Proof is done. Angle 1 plus 2 plus 3 is 180. That is the reason. You see, in school, when the teacher teaches you or the textbook tells you that the angle sum is 180, what is the reason? Why is it 180? Because of, do you see it now? Do you all see it now? Because you can draw a unique parallel. There's only one. By converse of AIAT, these two angles are equal. Notice that in school, there is a problem. Throughout the world, in schools, there is one problem. There may be many problems, but I know one problem. They confuse between AIAT and its converse. For them, it's the AIAT converse. They don't know. Or the only thing they know is that, well, it is alternate interior are equal. Or if they are equal, they are parallel. For them, they are both same theorem. No. All right. So we just proved that The angle sum in a triangle in Euclidean geometry is 180 degrees. So EPP implies angle sum of triangle is 180 degrees. So from less than or equal to 180 degrees, we went to equal to 180 degrees. In hyperbolic geometry, what do you think is going to happen? Angle sum will be, well, we will see. Hold on. Good. Now, psi, yes.
Sir, it will be greater than 180.
No, it will be less than 180 because remember,
Oh,
the angle sum is always less than or equal to 180. It can never be greater, okay?
okay, sir.
So in Euclidean geometry, we found that it makes it equal to 180. The only other thing is left is less than 180 degrees. You know, in Euclidean, in hyperbolic geometry, triangles look like this. Okay? You will see all the, I am going to make you an expert on geometry. Okay? All right. You see, I have an interest in you. I'm interested in you. I am more interested in you than you are in me. Because you can learn what you are learning from me from some other mathematicians in India. But I am very old. I want to pass on my knowledge to young people who love math. So you can then give it to other people. That's what I am doing. That's why I am interested, even more than you are. Now, wait a minute. Can we prove this? Can we prove that angle sum 180 implies EPP? If we can, then EPP and angle sum will be equivalent. Yes, Dakar, you understand? All we proved so far was EPP implies angle sum 180 degrees. So we can ask, hey, if you take a triangle in Euclidean geometry, can you prove in neutral geometry? Because in neutral geometry, you can have a triangle with angle sum 180. Why? Because it only says less than or equal to, isn't it?
Yes, sir.
In neutral geometry, there is neutral geometry. Part of that is Euclidean geometry. And part of that is hyperbolic geometry. Follow? Over here, angle sum is less than or equal to 180 degrees. Over here, angle sum is 180 degrees. Suppose you don't know there is EPP. Suppose you are told that every triangle has angle sum 180 degrees. Does that mean you can get EPP out of it? See, we got 180 degrees out of EPP. Can we get EPP out of this? Is that a good question?
Sir, I think I have an idea of how to do it.
Well, I'm going to do that. That is not easy, okay? Very few people in the world will be able to do that right away. You can do that. If we give you several days, you can do that, but not right away. The proof is not easy. It is nice little proof, but not easy. Yes, who wants to talk?
Sir, can I try it? Raghav?
Yes, Rahul.
Yes, sir. So first what we can do is we can construct a triangle ABC.
Say once more, say slow and loud.
Yes, sir. Sir, so first we can construct a triangle ABC.
Yes. And then what?
And then we can draw a line L such that angle 3 is equal to angle 3 above, like on the right of angle 1. So can I draw in show?
Are you sure?
Okay, sir. Yes, sir. So what I'm saying, like we can draw angle like this. Sorry, a triangle. Sorry, so 1 second. Yes, sir. 1 second. And then we can construct a line L such that this angle is equal to this angle. Yes, sir. Sir, so then angle 1 plus angle 3.
Wait. We have a small problem. You said we can construct. Well, how do we construct it? We can say there exists a line. I will grant that. There exists a line here that has the same angle. Okay.
Yes, sir.
And then what?
And then, so then by converse of AIAT, we can say that these two lines are parallel.
Wait a minute. You cannot assume converse of AIAT.
So, sir, by AIAT.
By AIAT, these lines are parallel. These lines, that is the converse, isn't it?
No, sir, I'm saying that when these both angles are equal, then
If these angles are equal,
yes, sir. So
then the lines are parallel.
yes, sir.
Yeah. Oh, that's not the converse. That is AIAT, isn't it?
Yes, sir.
Okay, don't confuse. We spend a lot of time. So you are not confused. Good.
Yes, sir.
So these lines are parallel. Agreed.
Yes, sir. So then angle 3, I'll type it out once. So then this is angle 3. This is
Where is angle 3?
sir, I've typed it, sir. And this is angle 2, and this is angle 1.
Okay.
And so then this is angle 3. So
Yeah.
then this shall be angle 2.
Wait. Hold on. Are we if the okay, by construction, isn't it?
Yes, sir.
We constructed it. Yes. Therefore, this okay, agreed. And now,
So 1 second.
how does it prove that there is no other parallel to this line through? Good try. I'm sure there are some ways of, let me show you another proof. Okay? Is that okay?
Sir, actually, I think we can do it. So with the earlier figure.
But to save time, let us do the following. Let me put on a proof, and then if you find you have a proof, you can give it to your TA and he will or she will pass it on to me. How about that? Okay, so
Okay, sir.
let us do that. If you have a proof, give it to the TA. I am going to assume that let me see. How do I prove this? Angle sum 180 implies ETP. Okay, I am going to assume proof by contradiction. And what will be proof by, how do I start this proof by contradiction? You want to prove this. What do you need to do a proof by contradiction in this direction? You have to assume what? The opposite of what you want to prove, Vagishan.
Yes,
Vagishan, you
so
have a question.
I had raised my hand like before because I had myself like made the proof where we are placing 3 rotations of the same triangle side by side with where their angles add up to 180, and then on the top there will be a
Well,
parallel line.
if you think you have a proof, write it down carefully, look at it and polish it and give it to the TA and they will give it to me. Now, let me show you a proof. I want to prove this by contradiction. How? In a proof by contradiction, what is the first step? You assume something. What are we going to assume if you want to prove this by contradiction? Anyone? If you want to prove,
We will assume that the angle sum is at 180.
no, if you want to prove P implies Q by contradiction, you assume what first? You assume
We assume not Q and P.
Yes, you assume not Q in addition to P. So what do we need to assume now?
Sir? Sir?
Assume what?
Sir?
Yes.
Sir, I had a doubt for something you said earlier, that the angle sum in the triangle has to be less than or equal to 180, right?
Yes.
Sir, however, I remember there's one riddle that says there's a hunter who has set up his base somewhere, and he goes 1 mile south and he meets a bear. Over there, he is about to shoot the bear, but the bear damages his gun. The hunter then runs 1 mile east and then 1 mile north back to his base. So, what color was the bear?
I don't understand
Okay.
the second half
Sir,
of the question.
Okay, sir. Let's say we have a hunter. He sets up a base somewhere, and he goes. Then he takes his gun and he goes 1 mile south.
You draw a picture. Can you draw a picture, or can someone help
Sir,
us?
Okay. If he goes 1 mile south, and there he meets a bear.
Oh, going south. Yes.
Then, could you not draw the picture? It might. Okay, fine. Then he over there he's about to shoot the bear, but the bear takes his gun and breaks it. So the hunter runs away. He runs 1 mile east, then 1 mile north, Siddharth, please could you not draw?
Yeah.
And then he's back at his base. So what color is the bear?
What color?
Yeah.
I don't understand.
Yes, sir. The reason is that it's like it's written
Okay,
because
wait a minute. Sai Charan
Yeah.
has he has an idea. Hold on. Sai Charan, can you answer this person?
It is a white bear.
yeah,
He's in the
yeah,
he's
because
in the
because
Antarctic
yeah,
he's in the Arctic
yeah.
region.
Because if you think about it, his end result should be something like this. So how is he back at the base? Right? Because he's like, no, not like that. That's what. These are the only directions he took, the blue lines.
Now,
So
is
how is
this
he back at the base?
has this something to do with
Yes, sir.
our
Because the answer is, let's say his base is at the North Pole. Then if he goes 1 mile south, his path will be something like this. He meets the bear, goes 1 mile east, and then he goes back. So then it works. However, the issue is that in this case, this angle is like 90 degrees because he's first moving southwards, then eastwards. This angle is also 90 degrees, and this angle will have some value. So in this case, isn't the angle some greater than 180? Right?
See, is he in Euclidean geometry?
No, but you said that in Euclidean geometry is equal, but you said in hyperbolic geometry,
In
it is
hyperbolic geometry. Oh, good.
Yeah.
Oh, now I understand. Okay. In hyperbolic geometry, oh, you are way ahead
So
of me.
is this not hyperbolic geometry or what?
Yes, it is. In hyperbolic geometry, there is no rectangle. In hyperbolic geometry, there is no rectangle. Okay? If you turned 90 degrees, and 90 degrees, you will not come here. You will come somewhere here only. You will not reach that point. If you are in a hyperbolic geometry, you will not be able to get back to that point. You have to then turn back. Because if you went in a straight line, but if you curve, then you can get back. Using straight lines, turning 90 degrees each 3 times, you cannot get back because rectangle, whoa, now I know why you asked, exists in hyperbolic geometry. Okay, now
what about the angle sum, sir?
Angle
Like,
sum
so
will
shouldn't
be
you
less than
introduce some
360.
other? Okay. So, or you could say it has
I
it is
will
not equal to 180.
Yeah, I will revisit this problem and prove it to you when we do hyperbolic geometry, okay?
Yes, sir.
Who asked me this question?
Devansh.
Devnesh?
Devansh, sir. Devansh.
Devansh.
Yes.
Good question. Whoa, you are so persistent. Very good. Yes, Sai Charan? Go ahead.
But sir, you said that in hyperbolic geometry, the angle sum of a triangle is lesser than 180 degrees.
Yes.
It contradicts all the way to neutral geometry because what Devan said as 270 degrees.
But that's not hyperbolic
Not
geometry.
270.
There is no
That's not
contradiction.
hyperbolic geometry.
There is no contradiction. In hyperbolic geometry, you see, if you construct something like this is not 180. In a hyperbolic geometry, a rectangle looks like this. What?
Oh.
That's how a rectangle looks like. You will agree with me. In about 3 days, you will be an expert in hyperbolic geometry.
Okay.
You will agree at that time that this is not the rectangle in hyperbolic geometry. This is the one. And if you draw a diagonal, you get a triangle, and the angle sum is less than 180 degrees. And here also it will be less than 180 degrees. We will revisit those things. But for now, where are we? We are trying to prove that angle sum 180 implies EPP. We will prove it, proof by contradiction. So in proof by contradiction, we will assume the opposite of what we want to prove. Assume this. So if we assume that and you get a contradiction, then this will be true. So we'll assume, we'll take this plus that. So let us see. Here we have to be very careful with this drawing. Because we have to be careful, I am drawing it carefully. Because, all right, how will I do this? I will take a point P. I have to show that I cannot get more than one parallel to L. I have to show that I cannot get more than one parallel through P to L. Is that what I have to do? I will assume the opposite of this. So wait. One way to construct a parallel is with this construction that we have done before. If we make this angle 90 degrees and this angle 90 degrees, then we know, is this line parallel to this line now? Is this line parallel to L now? Yes. Because of what theorem? Yes, that. What theorem guarantees that M is parallel to L?
It is AIAT and not its converse.
M is parallel to L by what theorem?
AIAT.
AIAT.
It's not the converse of AIAT. It's AIAT, not its converse.
Exactly. Exactly. By AIAT, M is parallel to L. Let us, but we are assuming the opposite of this. That means we are saying that there is more than one parallel. So let us see. Draw another line through P. Good. Let that also, call it N. So let N be parallel to L. Why? Because we are assuming the opposite of EPP, aren't we? Since we are assuming the opposite of EPP, there is at least one more parallel. Let N be one of them. Are you happy so far? I don't see anyone here now. This happens now and then for the internet connection. Sai, do you agree that I can put another line N that is parallel to L?
No, we can put a line N, but it's not parallel to L.
Wait a minute. It is
We
proved by
we think that it is true. If we think that it's true and that way, then it is parallel. Yes.
Yeah, you see, we are doing this proof by contradiction. Therefore, we are assuming that it is not EPP, okay? If it is not EPP, that means that we can have another parallel. Do you see that? There, that's why I
Yes.
wrote this. If we are assuming not EPP, then there is one more parallel to L, at least one more. Now, I'm going to call this Q. I'm going to call this R a point, this point S. Are you with me so far? Good.
Yes, sir.
Now, that means that angle RPS is greater than 0. Agreed? Because N is not L. Angle RPS is bigger than 0. Do you agree? If N is not N is not M, the other one is right too. Because N is not M, there is an angle between them. Agreed? If the angle were 0, N will be M, right? If this angle were 0, then N will be M. Agreed? Because they are not equal, this angle is bigger than 0. Do you agree? RPS is bigger than 0. Do you agree? What if RPS is 0? RPS, if it is 0, then N will be equal to M, wouldn't it?
But somebody asked me to unmute.
What happens if this angle is 0? Then this line will coincide with this line, wouldn't it? Then N will be equal to M. But we said N is not M, right? Right? By opposite of EPP, by assuming the opposite of EPP, we are able to construct more than one line. That is why this angle is not 0. In order for us to continue, you need to understand why this is greater than 0. Vagishan, do you get it? This angle is bigger than 0. Agreed?
If
Let us call.
this is equal to 0, then it would be equal to M.
Right. Let us call this angle, I don't know, alpha. Do you know the Greek letter alpha? Today, I want you to, at home, learn the Greek alphabet. Alpha, beta, gamma, delta. Okay. At least the first 4 or 5. Alpha, beta, gamma, delta. Okay. So this angle alpha is not 0. If angle alpha is not 0, then you can construct an angle that is smaller than this angle. How do you do that? Well, to prove that, I may need to use trigonometry, but you don't have to. You just say that if I go, let's keep going that way. If I keep going, if I go far enough, I can pick a point and join with this one. Let me if I take T, if I move T far enough, this angle, what will happen to that angle? Is it going to increase or decrease? If T moves to the right, what will happen to this angle? Will it become smaller or bigger? If T moves this way, this angle will get smaller and smaller, right, Sai Charan? Sai?
Yes, sir.
This will become smaller. So by moving far enough, I will be able to let T angle QTP less than angle RPS. RPS is fixed. It's alpha. Then I can find an angle, construct an angle alpha smaller than this by moving that way. That's actually called the Archimedean property of real numbers. Archimedes. Given a real number, there exists another number smaller than that. Obvious, isn't it? So you can find an angle that is smaller than this angle. Let us sit right there until everybody is happy with it. Somebody gives you an angle 1 degree. Suppose this is 1 degree. Couldn't you find an angle less than that? Actually, what you can do is, you go here, let us say this is 2 inches, then you construct a circle here, then if you go more than 2 inches here, this angle will be less than that angle. We know that, don't we? We know how to go far enough so that this angle is smaller than that angle. By Archimedean property, it is possible to have an angle that is smaller than that angle, and we can construct it. I could use trigonometry to construct it, but I won't you believe it. So I say that angle QTP is less than that. Now let us see what happens. Something very funny happens. I'm going to erase all this so I can finish the proof. Can PS be inside this triangle? Can PS be inside this triangle? What will happen? What will happen? Or is P, like, can PS come in like that? If PN, if PS come in, if N came in like this, then N will come and hit here, wouldn't it? There is a theorem that says, if you have a triangle, and if you go inside, and if you take a ray, that will hit this side, okay? It's obvious, but in mathematics, we don't rely on what is obvious. We have to prove it. In a triangle, I am writing again. In a triangle, if you have a line coming like this, don't you agree that it will meet this side? Yes. It cannot meet this side. What will happen? What will happen if it, instead of meeting this side, what is wrong if it went out that way? What will be the problem? If it, yes, I.
Sir, it will be curved.
Then it will be no. Well, suppose this is a straight line.
Then it will be the line itself that is that.
You see, then there is a problem. Where
Be
it goes out.
intersecting on the line. It will be lying on the line.
Yeah. You see, if this is a straight line that is not the same as this, then we find that we have two straight lines joining the same 2 points. Agreed? Therefore, it cannot go this way. That's interesting. Therefore, it must come out through this side. So if N were to go inside, N will hit somewhere. Agreed? But N cannot hit this line. Why? We are assuming N is parallel to L. Agreed? N is not inside PQT. That means that angle, therefore this angle QPT is less than angle QPS. I need space. Well, if QPT is less than that, let's see now. We are almost done now. Then I will go over the proof once more. This is a very nice proof. So now what I'm saying, this angle plus this angle, angle TPQ plus angle QTP. TPQ is less than RPS. QTP is less than RPS. And TPQ is less than RPS. RPS. We got it from here. This angle is less than this angle, and this angle we just said QPT, QPT, TPQ is QPT. This angle is less than QPS. What is RPS plus QPS equal to? What is RPS plus QPS? RPS plus QPS is 90 degrees. So if we are saying that this angle plus that angle is less than 90 degrees, this angle being 90, what will be the sum of the angles in that triangle? If this angle plus that angle is less than 90 degrees, because this is 90 degrees, if you add all these up, you get something less than 180. Do you agree? And that is a contradiction because we assume angle sum is 180. And that is the end of the proof. Then angle PQ, angle sum of triangle PQT is less than 180, and that is that contradicts this here. So let me go over this one more time. We have 6 minutes. I'm going to send you the notes for this, by the way, guys. This is a lot of writing for you. So let me go over the proof again. To prove this, I am going to go by contradiction. That means there exists n parallel to L by, okay, let's all go together on this again. What happened to us, guys? I proved that there exists a triangle. We proved that there exists a triangle T. Triangle QTP where the angle sum was less than 180 degrees, which contradicts this, okay? And therefore this assumption has to be wrong. So let's see now. Our plan is this. We want to prove this by contradiction. So we assume the opposite of this, which is this, right? Is this the opposite of this? We assume the opposite of this. And if we can get a contradiction, that means that the assumption is wrong. Agreed? If we assume the opposite and get a contradiction, that means the assumption is wrong. That means it has to be EPP. That is our plan. If you need to understand the plan before we can proceed. How many people understand our plan? It must be your breakfast time. Sai, do you understand the plan?
Yes, sir.
We want to prove, if we want to prove P implies Q, by contradiction, we assume the opposite of Q, don't we? If the opposite of P and opposite of Q and P will give us a contradiction, that means it cannot be this, it has to be this. Agreed? So, to prove this, we assume the opposite of EPP and hope to get a contradiction, right? That is our plan. So, what is the opposite of EPP? That we can construct another parallel to L through P, and that's what I did. Agreed?
Yes, sir.
Good. Finally, I have a response from you. So that's how I got the N, by assuming the opposite of EPP. But if I get N, there is an angle there. Therefore, angle RPS is not 0. Agreed?
Yes.
Because N is different from M. N is different from M. If RPS is bigger than 0, I can construct another angle going far enough. Angle QTP, tell me, is less than RPS.
RPS.
RPS. You can go far enough, make it so small that it is less than this. Agreed? If I can do that, we made just one observation. Can this N come through here? If it came through here, it will get out through here, wouldn't it?
Yes, sir.
If it gets out through there, can it be parallel to L?
No, sir.
Therefore, it cannot get through here. Get it?
Yes, sir.
It cannot get through, it cannot come inside this triangle. So that means that this angle is smaller than this angle is smaller than that angle. Agreed? So
Yes.
I can surely write N is exterior, is between what is this? PT and PR. Okay? N has to be here. Then we have angle TPQ less than angle SPQ, right? This angle is smaller than that angle. And we are almost done then. That means that this angle is already smaller than this angle, isn't it? By construction.
Yes, sir.
So that means that angle QTP plus angle TPQ QTP is less than RPS. TPQ is less than
Angle SPQ.
SPQ. But what is RPS plus SPQ? RPS plus SPQ
90.
is 90 degrees. That means that this sum is less than this plus this angle plus this angle is less than 90 degrees. If that is less than 90 degrees together, what is this angle? By construction, it is 90 degrees. So, if these two together are less than 90 degrees, and if this is 90 degrees, what is the sum of all these three?
Less than 180 degrees.
Less than 180. Whoa, that contradicts this. Therefore, our assumption is bad. Therefore, we have proved EPP. Are you with me?
Yes, sir.
That is the proof. You can see that the proof is not long, but it is kind of difficult to see it. This proof I am going to write down and send it to you, okay? Just in case somebody wrote it wrong. So we have proved that angle sum, we thus proved that angle sum, oh, what did I do here? Angle sum, angle sum, 180 degree in a triangle if and only if EPP. Wow. Okay. So what is the reason that every triangle in the Euclidean plane is 180 degrees? The reason is what? That is why. Okay, Raghav? The reason why in school the teacher says to you that the sum of the angles in a triangle is 180 degrees, the actual reason even the teacher doesn't know is that it is EPP. Most people in the world don't know this. Even professors don't know this, most of them. Because, you know, they are busy with their mathematics. It has many, many branches, okay? If you are an expert in geometry, then you will know this. But this is not supposed to be a specialized, this is supposed to be part of the general instruction of a mathematician, okay? Knowing neutral geometry thoroughly, which is what is going to happen to you in the next few days. Knowing this thoroughly will give you great confidence in geometry. You will feel the power. You will feel so happy. A lot of confusion will be gone. Now, let me see if I have bad news for you today. I have a sad news. The bad news is I have no homework for you. Because the one I can give you would be too hard. Okay, so today there is no homework. All right, that's the end of the class. Are we learning anything good? Okay? Good, good, good. Excellent. See you tomorrow.
Yes, sir.
Actually, sir, are we really going to believe that a triangle is going to be 3 curved sides in the next few days?
The next 2 days, you are going to be able to teach other people
What?
that there
About
are
this.
triangles that have angles some 179 degrees.
Why I was wondering